All right, so what do we do, though, if I don't give you a factor to start out with? So what if you're given a polynomial, but you're not given any clues as to what one of the factors may be, so you can start the whole synthetic division problem? Well, simple thing is, if I don't give you a factor to start off with, then you're going to use your calculator to find your own root. So you're going to graph it and look for x-intercepts. Okay, so here's what's going to work out. If you can graph it and you can find all the roots on your calculator, you're going to be able to just write them down and move on. When you can't find all of them on there because maybe only one of them is nice and the other two are irrational or imaginary even, then you're going to have to do some of the processes that we've been looking at here. So if I give you a quartic, which is a fourth degree, then you'll have to do synthetic twice before you are at a quadratic, which is the second degree. So once you're at a quadratic, then you can factor, complete the square quadratic formula to find your other two roots. But you've got to get it down to something x squared, essentially, before you can use those techniques. So if you start with something to the fourth degree, you might have to do synthetic twice, because the first time we'll only get it down to a cubic, then the second time down to a squared. All right, so let's look at an example like that, where I'm going to start with a fourth power. So x to the fourth minus 2x squared plus x squared plus 8x minus 20. So how many total roots will the polynomial have, real or imaginary? Well, that exponent tells us how many roots we're looking for. So this one's going to have 4 roots. And remember from what we looked at previously, that just means 4. It doesn't mean they're 4 real. Just a combination of real and imaginary. All right, so our next step is we're going to graph the polynomial on a calculator, some sort of graphing device, and see how many real roots do I see, and what are they. So if I stick this in my calculator, x to the fourth minus 2x cubed plus x squared plus 8x minus 20. And hit graph. All right, so I can see that it passed through twice. So there are 2 real roots that I can see. And I want to know where those real roots are. Well, they appear to be at 2 and negative 2. If you want to know for sure, you can check your table, because the y should be 0 at this point if they truly are roots. So if you go to your table real quick and look at negative 2 and positive 2, the y should be 0 if they're roots, and that's what we're seeing. Okay. So how many real roots do we see? We see 2 roots. And where are they? Well, they're at x equals negative 2 and x equals positive 2. All right, so our next step is to use those roots to factor the polynomial down to a quadratic. So we're going to have to do synthetic twice. So you're just going to pick one of these. Doesn't matter which one you start with. You'll get the same quadratic in the end. So I'm going to start with the positive 2 first. Okay, so I've got that fourth degree polynomial up there, writing all of those coefficients in. Start the process. So bring down the 1, 2, 0, 0, 1, 2, 10, and 20, which gives me a remainder of 0. So now I'm basically down to a cubic. I now have x cubed plus 0x squared plus x plus 10. So I'm just going to now do the whole process again with the second root that I found. So bring down the 1, negative 2, 4, 5, and there's my negative 10, which gives me a remainder of 0. So now I'm down to a nice quadratic, x squared minus 2x plus 5. And once I get it down to that quadratic, now I can use my techniques. So find the remaining 2 using quadratic formula or completing the square. Now because I couldn't see them on the graph, that should be a clue to me that I'm looking for imaginary roots. Something with an I should pop up. So let's do the quadratic formula on these. Alright, so x equals 2 plus or minus the square root of, that would be 4 minus 4 times 1 times 5, all over 2. So I'm going to get 2 plus or minus the square root of, this will be 4 minus 20, so negative 16 over 2. Clean up your square roots. Negative 16, that's our 4i, all over 2. So we're definitely getting imaginaries, what we were expecting. And then reduce all of these coefficients by 2. So we're going to get 1 plus or minus 2i for those 2 remaining roots. Alright, so it wants us to now just kind of list all 4 of them. So we found 2 on the calculator, negative 2 and 2. And then we found these 2 imaginary with the quadratic formula. We found 1 plus 2i, 1 minus 2i. So there is all 4 of our roots. Okay? So in this case, I didn't give you any to start with, so you had to start with the calculator. Got all the real ones that we could find, and then use a synthetic process to help us from there. All right, so let's look at these 2 down here. So trying your own. First one, got a nice little cubic. So I'm not given anything as potential roots, so I'm going to start with graphing again. So I'm going to stick that in my calculator. So x cubed plus 7x squared minus 16x minus 112. Okay, another graph. Because my exponent was, the highest exponent was a 3, I know I'm looking for 3 roots. And this time I'm getting lucky, and I'm seeing it's crossing through 3 times. And they all look like they're at nice integers. It's like, what, negative 7, negative 4, and 4. Just going to go to my table to double check that. Alright, so there's my negative 7, 0, my negative 4, 0, and I'm going to check for the positive 4. There it is, right there. So I can see all 3 of the roots on my calculator, and so I don't really need to do any more math. I'm just going to write those roots down. Call it good. I don't have to do any of the other processes if I can find them all on my calculator. Okay? Alright. Let's go to the last one. So this time I'm back to something with a 4th power, which means I could potentially, if I can't find them all on my calculator, have to do synthetic twice again, followed by like the quadratic formula. But we won't know until we graph it. So let's put it in the calculator. Make sure I've typed everything in correctly. And then I'll look at the graph. So x to the 4th plus 6x cubed plus 5x squared minus 6x minus 6. So it looks like I definitely see one of the roots at positive 1, Oh, there's another one at -1. And then I'm not seeing another one. So there's 1, there's -1. That means there's another one definitely where it crosses down here. But it's not at a nice spot. It's some sort of irrational or decimal, essentially. So we're going to have to find that. All right, so I know there's 4. And I'm seeing 2 real ones for sure. So I know I can find -1 and 1 from the calculator. Alright, so let's start our synthetic division process with those 2 first. Okay, so bring down the 1, -1, 5, -5, 0, 0, -6, and 6 gives me that remainder of 0. So now I'm down to a cubic. I'm going to use my other root I found on the calculator, which was 1, to do this one more time. And there I get that remainder of 0 again. So now I'm just dealing with this quadratic, x squared plus 6x plus 6. I've got to solve that. There are no factors of 6 that add to make 6, so I am going to have to use completing the square quadratic formula. I'm going to complete the square this time because I've got some nice numbers to work with here. I'm going to move that 6 to the other side. And then I'm going to figure out half of 6 squared is going to be 9. Add that to both sides. Factor this, so that's going to be x plus 3 squared equals 3. Get rid of the squared by taking a square root of each side. So x plus 3 equals plus or minus the square root of 3. Can't break 3 down, so all I have to do now is basically subtract this 3 to the other side, so -3 plus or minus the square root of 3. So I did get the real answers, but they're definitely irrational. So those 2 right there bring my total to 4. So I've got -1, 1, -3 plus root 3, and -3 minus root 3 for my roots. Okay? And again, that's kind of worst case scenario when you have a degree of 4 that you have to do synthetic twice. That could be a possibility. But you could get lucky like this number 1 problem where you graph it and you can find all of them on your calculator, and then you don't have to do any of that work. You can just write those solutions down and move on.